Green. I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today is Doug Pelton, PLC Product Manager out of our Charlotte, North Carolina location. Out in the comments section, ready to answer your questions, is Hubert Wall, Automation Specialist, also out of Charlotte. We'll also have a Q&A portion at the end for Doug to answer your questions in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comments section. I see Hubert is out there, and also John. Thanks for joining us today. As we continue to socially distance, we're happy to be able to host these live sessions here on YouTube and make it possible for you to join us from the comfort and safety of your own homes and offices. As always, you can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist, and we will be continuing this series every Wednesday at noon, so you can join us on your lunch break. For anyone just tuning in, welcome to our Virtual Lunch and Learn SLC to CompactLogix migration solutions. Let us know where you're joining us from in the comments. Hi, Leanne, thanks for joining. We'll be looking for your questions as you have them in the comments section while our presenter, Doug Pelton, talks to us about the life cycle and longevity information within the SLC and CompactLogix products, and much more. Our specialist, Hubert Wall, is ready to answer your questions in the comments as we go through, and we'll also have a Q&A segment at the end of Doug's presentation to address some of those questions more and to allow time for follow-up questions. If you'd like to reach out afterward, or if you have further questions for Doug, you can send us an email at that email address you see on the screen, mcmclive@macmac.com. Be sure to let us know which session you attended so that we can get your questions to the right person, and Doug will reach out to you directly. We'll have that email on the screen at the end as well. And hi, Rodrigo. Thanks for joining. It looks like we have a number of attendees now. So Doug, I'm going to pass it over to you.
Okay, thanks, Rachel. Hi, and thank you for joining today. As Rachel said, my name is Doug. I work in the McNaughton-McKay Charlotte office, and you're joining us here from the Charlotte Engineering Lab. And if you think, I bet that's his kitchen, well, you wouldn't be wrong. Today we're going to talk a little bit about SLC to CompactLogix migrations, some of the solutions that are out there, the technology that's available to you, some new technology that's been released recently from Rockwell Automation, and just talk about a couple different ways to skin that cat and migrate to a later platform to help avoid downtime abatement and modernizations. Again, if you have any questions, you can type them in. We have Hubert Wall answering questions, and we will do a live Q&A at the end of the presentation. So what I want to talk about today is the 1492 IO conversion system that's been released with the new SLC to CompactLogix modernization hardware. How the conversion system installs. Then we're just going to talk a little bit about the SLC 500 to CompactLogix 5380, specifically the 5380 control system modernization. So now, recently, Rockwell has introduced conversion chassis, conversion hardware to help with the help speed up the conversion process from the SLC controller to a 5380. It's providing us with an easy migration from a SLC to a 5380. It reduces I/O rewiring time and effort. Pre-wired removable terminal blocks that are provided in the system. This does retain the exact same footprint as your SLC I/O chassis. As a matter of fact, it utilizes the same bolt holes that the chassis was bolted to your backplane in. So we're going to cover the conversion modules. We'll talk a little bit about the 5380 controller, and we'll discuss the hardware, the upper mounting plate, lower mounting plate, wiring conversion, and the swing arm. And again, if you have questions, please go ahead and type those in, and we'll answer them as we go. So we have 4 frame sizes available, and these relate directly to the SLC that you have installed currently. There's a 4, a 7, a 10, and a 13 slot chassis. Each one of these chassis relates back to whether you have a 4, 7, 10, or 13 slot slick. And again, it bolts up to the exact same bolt holes and it has the exact same footprint. I do want to add that this adds about 2 inches of depth. We've generally not seen a problem with that because they're mostly installed in a 10 or 12-inch cabinet, deep cabinet anyways. So I haven't had any issue with that. I do want to go ahead and just bring that up. So these are the the parts and pieces of the conversion chassis. There's an upper mounting plate. As you see, there's DIN rail mounted on the upper mounting plate. That's where your 5380 controller and your Compact 5000 IO modules mount. The lower mounting plate is what mounts to your backplane, and that's where your conversion modules will mount. And before we get into all of that, there's a quick video that I'd like to show you, and this sort of steps through exactly how this process works. So let me cue that video up for us, and we'll go ahead and play that real quick. And I will stop this a couple times to explain what's happening. This would be your SLC controller and IO that's currently mounted with the removable terminal blocks. So the first step is to remove the terminal blocks that are currently in your SLC system. Then you're going to remove the chassis from the backplane and mount the lower mounting plate. Again, the lower mounting plate does mount to the same bolt hole, so there's no drilling and tapping. These would be the IO wiring conversion cables that'll be spec'd out with your conversion. And you mount those first and snap them into the lower mounting plate. What we're doing here is that these are the terminal blocks that were on your existing SLC that go into the conversion modules. Then we mount the upper plate. The upper plate is hinged. If there's troubleshooting that has to be done somewhere down the road, you'll be able to access the wiring that is behind the new PLC and IO. And then we mount the new PLC and the IO onto the DIN rail on the upper plate, and then plug in the other end of the conversion cables. So what this does essentially is it eliminates the need to change any wiring. There's not going to be any rewiring issues. Everything is long enough, everything works, and if it was wired up correctly and worked the first time around, it will work the second time around with the new system. What we're looking at here right now, there's currently 12 modules available for conversion. And on the left side of your screen, you would see the Slick IO that converts over to the 5069 or the 5380 IO. And these are the conversion cable numbers that we spec for that conversion. Again, this includes the removable terminal block, and as you saw in the video, it's plug and play. So that's what we have available currently, and it covers the vast majority of the SLC IO, and I do believe there's some coming out for some third-party providers as well. So the installation procedure, we covered that in the video, so I'm going to I'm just going to kind of breeze through this real quick. I did want you to see things like the 1492 conversion modules, and this gives you a little bit of a different view or perspective than the video did, and how they snap onto that base plate. And then this is installing your RTBs. Once your PLC is installed on the upper plate, there's the removable terminal blocks that you just plug into your I/O, and then you're all set there. When we do want to talk a little bit about the Logix 5380 controller, this conversion system is for the 5380 controller and only the 5380 controller. It does not, the form factor is different with the 5370. But the 5380 is a high performance controller. It's a 4-core controller. The firmware is optimized for maximum performance. It actually has a core that handles Ethernet communications on board on this controller, so there's no need to programmatically configure a 20 or a 25% time slice for Ethernet communications, which means you utilize 100% of the controller. The controller also has dual 1 gigabit Ethernet ports and can support up to 32 axes of SIP motion. Those Ethernet ports, those dual Ethernet ports, are configurable. You can use them as a device level ring, or you can separate those out into 2 separate subnets. So if you have a if you have a local I/O network and then an enterprise network that you need to communicate with, you can do that without the aid of another device. 31 local I/O modules, and we can go from a memory from 0.6 to 10 megabytes. We have a 10 megabyte controller in this small form factor. Very high performance, very fast communication across the backplane with gigabit Ethernet speeds. So the SLC 500 to CompactLogix control system modernization. Couple things that we want to talk about is where they are in the life cycle. This is the SLC controllers. Rockwell's life cycle consists of active, mature, end of life, and discontinued are the categories. A great many SLC controllers are in that active, mature phase right now, which means they have approximately 5 years. Many of these have been moved to active mature already for a couple years. So I can't give you discontinuation dates from Rockwell, because Rockwell doesn't share that information with us until they share it with the public. So I can't give you that. I can tell you that there are certain things that are planned for end of life that they have announced. For instance, as you see on the slide, the 1746 NI4, NI04I, these are planned for May 31st of 21. The 1746 P1 is planned to be end of life September 30th, and there are several modules that are already discontinued. So what that says is, where does that put you? If you have SLCs in your plant, it's time to look at a migration path and maybe get a migration schedule out there. But just be aware, you can also check the status, your life cycle status on Rockwell's life cycle status website. So a couple different ways that we can do migrations and modernizations now are, we looked at the migration hardware, but Rockwell makes a 1747 AENTR module. What this allows you to do is with a like a 505 Ethernet controller, you see on the top, it's specific to Ethernet, it allows you to take a CompactLogix or a ControlLogix controller, remove your SLC controller from your chassis and replace that with a 1747 AENTR. What that does is allows you to hang on to your current SLC I/O, and it just becomes distributed I/O to the controller. Once you scan that, it pops up as in your I/O tree as distributed I/O. That works with generally all of your simple I/O cards. it doesn't necessarily work with third-party cards. So if you have a SLC chassis with spectrum control cards, or you have some Hardy Wayscale modules or things like that, I would recommend calling your local distributor and talking to their engineer about what works and what doesn't work there, and let them help you specify that. Additionally, with the 5380 controller, we've come out with a 5069 serial module. So if you have a legacy serial network, DF1, DH485 network on your controller, you can go ahead and utilize the 5069 serial card and still use pardon me, and still use your serial network should you choose to do so. So just so you know, that's available for DF1, DH485, and that's out there. So with this, you can retain your I/O. Why would you want to do that? Well, if you wanted to do a phase migration, you wanted to replace the controller and then budget for the I/O next fiscal year. If you have a great deal of SLC spares in your storeroom, you might want to do that. There's several reasons that you may want to go down that road, but again, this is one option. This slide, we put this together to show you it's just a quick reference of the SLC controllers and the recommended migration path and what controller you may use. If you look down the first few rows, these SLCs, the 01s and 02s and 03s were only 16K controllers, 32 at best. They're showing a replacement as an L306ER. That's a very budget conscious controller. It's a 0.6 megabyte controller, but it will handle anything that was in your SLC at the time. And then as your SLCs increase in memory, we increase the what controller we recommend to replace that product. We did talk a little bit about the serial module, but I just want to cover a couple quick facts on here. It is a 2-channel 9-pin D sub, supports RS-232C, RS-422, and RS-485 media. So what does that mean? If you wanted to do ASCII, Modbus RTU, master slave, Modbus ASCII, it will function in that environment. Additionally, DF1 and DF485 functionality are compatible to replace the 1769 L23, 31, 32E, 35E, and the L4 controllers. That was the prior generation of CompactLogix controllers. The 1747 AENTR module that you see on the bottom right, that we would use to replace a SLC controller and then reuse your SLC I/O. It must be in the first slot of the rack because you're scanning the I/O after it, not before it. You would need version 20 or greater. So version 20 of RSLogix 5000 or 21 and greater of Studio 5000. We're currently on version 32 with version 33 being released shortly. It does support a device level ring network topology should you choose to use that. If you're not familiar with device level ring, it's a ring type network that's fault tolerant. There's more information on that on the Allen Bradley website. So we want to talk about some of the resources. I'm going to hold on this screen for a minute if you would like to take a screenshot of this screen for the links. The graphic on the right side of your screen is going to be a wizard that's located within Integrated Architecture Builder. Integrated Architecture Builder is a free software tool that you can download from Allen Bradley's website. And what we're showing here is the SLC migration module selection screen. So what happens is you're able to download this free tool onto your computer, pick your build your SLC that you currently have. So it's going to give you options as you see, they picked an L540 processor and drug that over into the chassis. They chose a 4-slot chassis, and then they're choosing their I/O. And what happens with this is as you drag and drop that I/O over into your slick chassis, it will build out your migration chassis for you. And you can choose if you want to build that out by keeping your slick I/O, or if you want to replace it with CompactLogix, or if you want to replace the I/O with the CompactLogix and the conversion hardware. So it builds everything out for you. The last piece of the puzzle for your conversion is converting your program. Now there is a conversion tool in Studio 5000. It allows you to import your RSLogix 500 program. It converts all of your code for you. And at the end of the conversion, it creates an exception report that will tell you what wouldn't convert. You know, there may be some operands, atomic operands that were used in the bit-based world of Logix 5000 that do not work in the tag-based world I'm sorry, in Logix 500 that don't work in the tag-based world of Studio 5000. But it does tell you what it is that needs to be addressed and where it is. So that's a great help in converting your code over. It also takes the atomic addresses that were in RSLogix 500 and utilizes those within the tag naming convention. So if you have a tag of B301, it's that address is going to be embedded into the tag name of the new tag in Studio 5000. So it makes it very easy to follow. ProposalWorks is a file that you can generate. It's another free download from Rockwell. And let's go back one slide. When you generate all of this hardware and integrated architecture builder, you can at that point export that into ProposalWorks. We are on version 11 now. Again, free download from the Rockwell website. And what happens here is it gives you a very detailed bill of material. If you know your current pricing from your local distributor, you could plug that in and this will price everything out for you. If not, you can just go ahead and send this bill of material over to your local distributor and they'll generate a quotation for you based off of that. You can also use the wizards involved that are embedded in ProposalWorks to change wiring conversion modules. Anything that you need to change or add can be done right in there. And this can also be embedded back into your IAB file, so that any changes that are made here would also be changed in Integrated Architecture Builder. So some of the resources. Again, I want to kind of leave this right here for you so you can take a screenshot and look at these links if you need to. The SLC 500 to CompactLogix 5380 control system migration. That page covers everything that we covered here today. Plus, it goes a little bit further in depth on the serial side of things. If you are a MicroLogix customer and want to migrate off to CompactLogix, there is the migration guide available for that as well. Plus, there's we also have several publications that address the last generation of, I mentioned earlier, like the L23s, the L35Es, and the L4s, migrating those to a current level. I think all of those are now obsolete. They're at end of life, and everything but the MicroLogix 1400 is end of life right now. If you are familiar with the knowledge base, the Rockwell knowledge base, these numbers, these tech notes cover everything that we just talked about. If you have a more detailed technical question, these go in a little bit deeper than just the general sales pitch that you'd see. I do like the 21410 ControlLogix configuration and status flags. That's a very good article. And the frequently asked questions on the 5069. That's a very good article as well. Also, there is a webinar on migrating the old 1768 to controllers to a 5380. So that. And the other tools you can, like I said, you can download Integrated Architecture Builder. That's a free download. When you download that, it comes with Proposal Works. You would go ahead and download that and go and do an update. That's a live system that Rockwell updates continuously. I probably, in my role within the company, use that just about every day. So I don't have to ever do large updates. But I will warn you that if you use this, infrequently, the updates will take quite a bit of time. We talked about the product lifecycle status. If you just type that right into Google, Rockwell product lifecycle status, it'll take you directly to the page. On their product lifecycle status, you type in the catalog number of the product, and it'll tell you where it is in that life cycle. And if it's an end of life, it will tell you when it went end of life. So that sort of gives you a pretty good idea of where you are in that life cycle with Rockwell, whether you're current and just so that you know, active mature doesn't necessarily mean it's going away anytime soon. It means that there is a newer technology that they've released that basically does something the same as a product that is out there. I believe if you checked any 5370, it may be called active mature right now, even though the 5370 product was never meant to be replaced by the 5380. The 5380 was just a different animal on a high performance offering. And you can look at other modernization tools and services on rockwellautomation.com website. And that is about it. And I think I took you guys to exactly 30 minutes. So I'm pretty happy with that. I thought it would take me 40. So Rachel, do we have any questions out there?
Thank you, Doug. It does not look like we have any questions live at the moment, but we will give a second here to see if anyone has any follow-up questions for this Q&A segment. While we wait to see if anyone does have questions, I'll just remind you that you can always reach out, even if you're watching this as a recording, at that macandmaclive@macandmac.com email address. Just be sure to let us know which session you attended, and we'll get your questions to Doug directly so he can respond to you. And with that, it does not look like we have any questions at this time. We have some thank yous and great jobs in the comments section, Doug. So thank you for that wonderful presentation.
Thank you. I thank everybody for joining.
I did too. Thank you for everyone joining us today and giving us some of your time on your lunch break, and for everyone watching this as a recording in the future. And thank you, Hubert, for being our resource in the comments section today. We hope the session was informative and engaging for you, and please remember to subscribe to our McNaughton-McKay YouTube channel for more industry content. We look forward to seeing you live again at the next virtual Lunch and Learn. Thanks, everyone. Have a great day.
Thank you. Okay.
All right.